Okay, this is my review video for the cumulative number 5, and it covers some of the hardest trig stuff we have. We're not going to be able to cover everything, but at least I'll get to remind you of a few things. Number 1 on the packet, I have already rewritten. It said arc cosine of root 3 over 2. I said inverse cosine. See this little -1? Do you remember the first thing I asked you to do was to rewrite these? That was the first thing. In case you forgot that, I would recommend you write it as cosine of theta is equal to root 3 over 2. Because see, now you can tell very clearly that the thing we don't have is the angle. The thing we do have is the two sides. So we got to try to figure out where can we get an angle that would have sides like that. Does root 3 over 2 sound like one of those triangles we knew? Yes, and therefore, a good Minnesotan answer. Oh yeah, you betcha. Pass the tapioca. All right, so, and then I'm going to hop in the boat later. Okay, so anyway, square root of 3 over 2. So where is cosine positive like this? See how it's positive? All students take calc. Rule those out because cosine's only positive in A and the C area, the quadrant 1 and quadrant 4. So I better draw myself a triangle right there that has cosine ka adjacent over hypotenuse. Adjacent's root 3, hypotenuse is 2. Remember that? So then the one that's across from the 1 here, see, that one must be a 30. Remember that? What do we call that in trig? Pi over 6. Yep. So pi over 6 is one of my answers. And is this a question where they find all the solutions between 0 and 2 pi? No. So therefore, I can leave it like that as pi over 6. They didn't ask me for all the solutions between 0 and 2 pi. Correct. I understand what you just said, and I'll say it again. You can just have one answer. All right. Okay. Let's try now the one like number 7. I was asked about number 7. I can come back. Yes?
What are you doing differently when you have the negative?
What you're doing differently is they have given you a side here. Normally, trig has an angle right next to the cosine. See, that's why I tell you to rewrite it. Please stop talking. Shh. I know it helps you think. It doesn't help me. It makes me very distracted. Ask me questions if you want, but don't talk while I'm explaining stuff. Okay, so this right here, I have rewritten the original problem, and that's what I would want you to do. So you can see that you're finding an angle now. They gave you two sides. But this really is as simple as that. They've given you two sides. You need to find the angle. And you got to figure out are you in 30-60-90 or are you in the 45-45-90. It's usually one of those two. Yes?
Did you teach us something that was like tangent only works like this?
Yes, we'll get to that in a moment. Let's do that number 7 you were talking about. It'll come in handy there. So really the question is, where is inverse cosine allowed? That's what you're getting at, right? So we can talk about that in this problem too. Where is inverse cosine allowed? Inverse cosine is only allowed between here and here. Do you remember that? Yep, that's where cosine's allowed. If you've forgotten that, this would be one of those things that would help you the night before the test. Make yourself this little chart. Here's where they're allowed. If you're doing an inverse problem like this, you got to be careful. You're only allowed to give answers in certain areas. Inverse cosine's only allowed from there to there. That's the only place you can do inverse cosine. Do you remember where the other two are? They're both the same spots. Yep, they're on the right-hand side. So, like this and this. And those two are inverse sine and inverse tan. So inverse sine and inverse tan are the green ones. They're only allowed in quadrants 1 and 4. And the inverse cosine is only allowed in quadrants 1 and 2. Any questions about that? So that would be another good reason to say we don't need that other answer, because that other answer, Mr. C, you were talking about the other answer? The other answer is not possible, because why? Nope. It's only allowed from here to here. That other answer would have been in there. See how it's not allowed? This is where cosine's allowed, in this zone. Okay. Let's move on to problem 7. Problem 7, everybody, please look at number 7. And if you already did it, see if you did it right. Where do you start a problem like that? On the inside is correct. And it's inverse tan on the inside. you act like the outside doesn't even exist and you focus on the inside, one thing at a time. This right here can be rewritten. So you write it as tangent of theta has to equal root 3 over 1. Do you get how we're trying to find an angle now? Am I doing it right?
Yeah.
Okay, good. Now, where is inverse tangent even allowed? Only there to there. So you get how I can cross off those two? Now, after I rewrote it, it became more clear that this and this was a side. Are my sides both positive? Yes. So tangent is positive. That narrows it down to it has to be in here because tangent would be negative right there. See, there's only going to be one possible triangle I can draw. Okay. Now, in that triangle, I have to have sides that are opposite root 3 and hypotenuse. No, wait. Tangent is opposite over adjacent. Adjacent is 1. So I can tell I'm in the 1, 2, root 3 triangle, and I can tell that this angle right here is not the 30 because it's not across from the 1. So that must be a 60. So if that's a 60-degree angle right there, then that, I should say, in radians is pi over 3. You get that? Now you have a whole new problem. Now I can look at the outside. Cosine of, what did I just figure out? Pi over 3, also known as 60. Does that have any restrictions on like where I can do inverse and all that stuff? No, this is a normal function. This is just cosine. So I don't have to follow that rule now. But did it ask you to find all the solutions for it between 0 and 2 pi? Or did it say find all solutions where you get 2 pi n thing? No, didn't say any of that. All right, so let's just find an answer that would work. Cosine of 60. Well, it's also a 60-degree angle, so I wouldn't have minded if you said 60 right there because we're not done with the problem yet. Because the 30, 60, 90 is a pretty common triangle. And if this is 60 and I'm doing cosine of 60, if that's the 60 and this is the 30, then that's a 1 and that's a 2 and that's a root 3. Do you have so I did that? Okay, so cosine of the 60, adjacent over hypotenuse, 1 over 2. There we go.
So you just said if you did cosine over 60, would that be right?
The answer is not cosine over 60.
I mean, if you did cosine of 60.
Cosine of 60 is equal to a half. You can't leave the problem as a question. If you left the problem as cosine of 60.
No, I know that, but like,
In other words, do I have to have the pi over 3 there? No, only because we're not done yet.
Okay.
If the answer is a final answer, we want it in radians. But this wasn't a final answer anyway, so the final answer is a half. All right. Okay, as soon as you come to an impossible thing, the whole problem is done. If you know that something's impossible, like you're right, number 9, when you look at the inside, you'll realize, I hope, that sine of theta cannot equal 2. That's what it wants you to do. Sine can't be 2. So, all right. All right. Mr. U. Yeah, but you don't have a pencil, and did you just do the problem we just did? Which problem was it? You're back on number 7, huh? All right, let's move on. Just seeing if you're paying attention. All right, so let's go to number 16. That one looks like fun. Oh, wait, that's the unit we just did. All right, I'll tell you why I was going after you, because you two were talking over there again for like the 17,000th time. I'm getting tired of it. Okay, moving. I don't care what it's about. You're talking. See, you're talking again right now. Okay, moving on to, let's talk about number 20, because that one is a little different. 15 through 19 are a repeat. Frankly, it's probably the hardest section of the test again, of course, because it was the hardest of the 3 tests. I would practice it if I were you. I would do all of 15 through 19. I just don't want to waste class time talking about it again because I spent the first half of class going over how to do those kinds. So let's move on to number 20. Number 20 says 2 sine theta, or sine x, is equal to -1. And it wants answers between 0 and 2 pi like this. And that means never use 2 pi. Don't forget that. Okay, so now, if I said sine x equals -1/2, boy, from there it ought to be pretty easy for you. There's 2 answers. You know, this is kind of like a subset of what you just did on the last test. Like when you got halfway done with your problems, then they were this easy. So this is an easy test relative to the other one. Because like you don't have to do the whole complicated factoring thing first and you break it in 2 parts and then it finally looks like this. they start out like this. Yay. Okay, so then, how do I do it? Where is sign negative? Sign is positive here and here, so sign's negative there and there. So I better get two answers for this, and let's see, make sure I do my sides right. Sine is opposite over hypotenuse. Why am I not making the hypotenuse negative? Because it can never be negative. Sine of this angle is sine is opposite of hypotenuse, hypotenuse. There we go. So then what are my angles? Well, if I'm across from the 1, I'm across from this 1 here, I hope you know that that's a 30-degree angle, but it's got to go all the way around here. So 30 is also known as pi over 6. So that's a whole bunch of pi over 6s. Specifically, it's 11 pi over 6, right? I'm pretty sure that's 11 pi over 6. All right, good. And if you were thinking it's negative pi over 6, you're thinking back to those inverse problems. On those inverse problems, you do want to give answers like that. You know, like if it was down here, you'd want to give a negative answer on those inverse problems. Remember that? Okay. All right, yeah, I'm not done yet. That was one of my answers. Now the other answers for this guy right here. And that one, if this is a pi over 6, then I got to go like this to get there. So that's a whole bunch of pi over 6s. 6 pi over 6 to get here. One more would make it 7 pi over 6. Okay, that was problem number 20. Any more questions about that one? All right, let's look at a different section. Look at number 23. Number 23, that's a lot like the test you just took, where you had to factor. So I hope you can factor that one. Maybe 23 is pretty dang easy. Let's look at 24. Number 24, that one's got a tangent and a cosine squared in it. Maybe you should get it all into sines and cosines kind of thing. Or maybe we should change the cosine squared into something else. But we got to somehow get it down to just one function. So you tell me, on number 24, any bright ideas? Can you factor out the tangent? Well, actually, I think you can. Maybe we shouldn't have to replace that cosine with anything. Let's just factor out the tangent and see what happens. All right, so if I take a tangent out of everything, there's one term here and one term here, and yeah, they both have a tangent in them, so that seems like it's going to work. Okay, yeah, they both have a 2 in it. Good point. I'll take a 2 tangent out. And then what will I have left? 2 times, see, I'm double checking this, that times that. Does that really equal 4 tangent? Yes, it does. 2 tangent times 2 is 4 tangent. Plus, what is to go here? Well, I've really divided this by 2 tangent. That's what you're really doing when you're factoring something out. And that's going to cancel that, so it's just cosine squared. Equals 0. Yes, we can do it that way. I thought we'd have to like do something first before it would factor, but this one's actually nicer than I thought. It factors right away. So there's one part of my answer, and it has to equal 0. 2 tan x equals 0. And then here's my other side of the equation. That has to equal 0. 2 plus cosine squared x has to equal 0. Divide by, or subtract 2 from both sides. Cosine squared x equals negative 2. Well, it's squared though, so maybe I should fix that first. So let's do the square root on both sides. Square root, square root. Now I'm running into real issues because I'm doing the square root of a negative. Am I allowed to do that? Only with imaginary numbers, so I'm going to say no solution on this side. Does that mean the whole problem is no solution? No, just this part of it. This might still have a solution that could work. All right, so I'm going to divide both sides by 2. And there we go, no solution. Dividing by 2, 0 divided by 2 is still 0, so tangent of x is equal to 0. That seems possible. Is tangent ever 0? Well, you got to go back to what tangent is. I'm obviously not going to be drawing myself a triangle for a side of 0, right? Therefore, if it's one of those kind where you can't draw the triangle, maybe you should think about one of those quadrantals, like this, 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 or this. And where is tangent again? It's y over x. Where is y equal to 0? Y equals 0 is definitely not here, because that's where y equals 1, right? y equals 0 is that spot and that spot, right? Okay, let's double check those now. This spot is really 1 comma 0, and this spot's really negative 1 comma 0. Would both of those spots, when I take y divided by x at both spots, would it equal 0? Y divided by x, 0 divided by 1, that's 0. 0 divided by negative 1, that's also 0. So bottom line, this one's pi, and this one is 0. Okay, we're done with the announcements. So here is my two answers, 0 and pi. All right, moving on. Let's look at problem 25. That was on our last test, but it was one of the easier ones. It was problem number 3. Okay, just a second. I just want to show people that cosine of pi over 12 is a real pain, but you can change that really quickly to something better. Don't talk now, please. Pi over 12, I could change that to radians really quick and easy. I just go off to the side, pi over 12. Do you remember how to change it to radians? It's pi over 180 or 180 over pi. And if I go this way, obviously the pi's won't cancel, so that was a bad idea. So then I put the pi on the bottom, 180 over pi, and then the pi's will cancel, and now it's 180 over 12, and I'll figure out it's what, 15? 15 degrees. They're really asking you for cosine of 15 degrees, and that'll be easier. Now you can say cosine of 15 is really something plus something or something minus something. Realistically, if I was going to do plus, I'd have to use like 10 and 5, and I wouldn't know what cosine of 10 is. So I'm going to use big numbers and subtract. 45 minus 30. And then you got to look at, and we'll have a sheet for you again of things that are facts. Like in this one, you'd be able to look up on the sheet. And cosine is, let me look it up on my sheet quick. Is it cosine, sine? Okay, so cosine, sine, sine, I use the opposite sign. So if this was a minus, I'm going to do cosine, sine, sine, and this is a plus, and that was all given to you on the sheet, and this would be 45, 30, 45, 30. Figure all that out using triangles and multiply them together. All right, and now let's talk word problems for a minute. All right, remember, some advice about word problems. I know we're close to done, but we're not done, so listen, give me one more minute. On your word problems, make sure that you look at your triangles. You've got to set up triangles, and it's pretty much always going to be either a triangle or a circle. If it's a triangle, you'll be able to do, you'll be able to do trig on that problem. If it's not a triangle, you'll have a different kind of trig. It'll be a circle with a little wedge like this. Do you remember the formula that goes with that kind? S equals theta r. S equals theta r. And the theta has to be in radians. Remember that. So if they give you something with 20 degrees here, don't get sucked into using 20 in the formula or it won't work. You got to change your degrees into radians to make those work. If you set up a word problem for like a ladder up against a wall, and you've got this as 30 degrees, just remember to set up your formula, sine of, which is the opposite, sine of 30 is equal to the opposite over the hypotenuse, and so let's say that they want to know what the...
Sorry about the interruption again. Thank you.
Okay, so if this was, let's say, 12, then I'd say sine of 30 is opposite over hypotenuse, x over 12, and then you'd solve for x. You'd multiply both sides by 12. On this kind of a problem, since it says sine of 30, that is one you'd have to be able to get in your head. Do you get how we expect you to be able to do anything with 30, 60, or 45 in your head? Because those are all ones you can draw triangles for. But if this had been a problem like 28 degrees, of course you'd be able to use the calculator and type in sine of 28. We won't make you do anything really weird like that in your head. Okay, we've come to the end. If you want to ask more questions, stay after. I'll be here. Come in the morning if you need extra help. I will not be here Wednesday, of course, but any other morning.